Okay, so welcome to this tutorial on how to design beautiful recycler views that are list with enhanced performance. Let's see some common terms. Okay, in global, the recycler view uses an adapter to bind views to the view holder and recycle all views, so you don't need to generate new views and you have better performance. So the adapter is the responsible for providing views that represent items in a dataset. The position is the position of the data item. The index is the index of an attached child view. Binding, the process of preparing a child view to display data corresponding to a position. The recycle view is a view previously used to display data for a specific adapter position, may be placed in the cache for later reuse to display the same type of data again later. The scrap view is a child view that entered into a temporary detached state during layout. Scrap views may be reused between becoming fully detached. Dirty view is a child view that must be rebound by the adapter before being displayed. So here you can see an example. This is the scrapped view. So it enters the dirty view and then is recycled, and these views that can hold text view and image views, etc., can be reused if they go out of the visible zone, the visible part of the mobile. So you reuse this to not allocate new memory and be more memory efficient and have better performance. So how it works? The idea is that here is the active view. This is the recycler view containing all the views, and you scroll up, so it goes down the list or the recycler view. So this is a past view. So the past view is thrown away. Here are the unused views. So when they accumulate, you have a position that is very away. So this dirty view is called dirty view if it's very away from the visible view. And then you bind data using the adapter and you create an upcoming view. You inflate the view and you can present when the user scrolls. So these views that went out of the mobile screen, they are not destroyed, they are collected and recycled, okay? RecyclerView Pros. It supports animations, allow item decorations like borders and dividers, can be used as a list or as a grid layout, works well with diff-util for efficient updates, offers faster performance, okay, and requires using view holder pattern for a better performance. The adapter. The adapter is the glue between the data source and the recycler view. It's responsible for creating view holders. The adapter inflates the layout for each item in the list. Binding data. The adapter binds data to the views in the recycler view using onBind view holder. Returning item account. You can use this get item account to get how many items it needs to display. And core concepts. The adapter ensures each item in the dataset gets displayed in the appropriate layout. The recycler view. So the idea here is that you have here the adapter that binds data. This is the data source. So the idea is this is the view holder, so it passes the data to populate view elements, and the view holder can inflate all the linear layout or the current layout, so it can provide, and this is the recycler view that decides and communicates back, okay? Adapter. The adapter, as we say, it uses data source. It communicates with the view holder, so you can get the get item count, create new view instances. The view holder inflates the view instances and populate items with onBind view holder. This is the adapter. View holder. A view holder is an object that holds the view of a single item. It catches views like text view, image view, to avoid unnecessary find view by ID calls. This improves performance because views are recycled. So here you have an example. You have the data that is passed to the adapter, and the adapter will use the view holder to inflate and create a item inflating in the layout manager using the RecyclerView. Layout manager, RecyclerView, adapter, view holder, and the data source. So here is your database. It can be a Firestore database, a Mongo database, a SQLite database, any database, or even a JSON or an array of strings in your string file. And the adapter will communicate using the view holder to inflate the views, okay? This is an example of a list view and a recycler view. So the list view, as you see, it uses a lot of memory because even if you swipe out, the views are still on memory. In difference, the recycler view will, if this view is not used, it will recycle, reuse it to allocate new views, okay? Layout manager. The layout manager defines how the items in the recycler view are laid out. So the linear layout manager lays out items in a vertical horizontal list. RecyclerView pool is a pool of views that the RecyclerView can reuse to display data. Okay, here we can see an example of an application. Here is the visible mobile display, and when you scroll, this view that went out of the screen is a scrap view, and it will add it in an array to recycle views. It will convert into a dirty view and then recycle it, and it will go again to screen to improve performance. Diff util. Diff util is a utility class that can optimize the process of updating a recycle view. Instead of notifying the adapter of data changes directly, diff util calculates the difference between two datasets and updates only the items that have changed. Item decoration. So you can use, for example, dividers, background decoration between items. Item animator. Item animator defines animations that you can use when items are added, removed, moved, or changed, okay? To achieve very particular use cases with beautiful aesthetics for apps. Scrolling and scroll states. RecyclerView has built-in support for scrolling. It can detect when the user starts or stops scrolling and can respond to different scroll states: scroll state idle, scroll state dragging, scroll state setting, etc. Pagination, endless scrolling. So if you have a database that have, for example, thousands or even millions of items, pagination, also known as endless scrolling, is a pattern where more items are loaded as the user scrolls down the list. This is often implemented in a combination with linear layout and scroll listener that detects when the user has reached the bottom of the list. So you can repopulate your dataset. You can communicate with your database if the users scroll until the end, and you can repopulate and reconnect and rebuild all the wireframing of the recycler view, okay? Summary. Finally, summary. The adapter connects the data source. The view holder holds views for each item. The layout manager determines the layout. The recycling views reuses off-screen views. The diff util efficiently handles changing data. Item decoration, spacing, etc. Items. Item animator animate changes. Scroll states handle different scrolling behaviors. Pagination loads more data as user scrolls. Okay, so these are the core concepts to create powerful Android applications with large datasets. So thank you.